recording. So this is going to be day 3 of solving matrix equations, and this is the quiz. And I was saying that I really think that the quiz is actually harder than the assignment. I don't say that very often. I just feel like they didn't give you, like their examples they used were more basic. They threw in more fractions with the quiz than they did, I feel like, with the assignment. And so sometimes just that throws you guys off. So I'm going to try to touch base on some of these things and make sure to point out some things to watch out for or things that you might have difficulty with, and some extra things that maybe you just forgot that you knew it, but you've already seen it in the past. Just, you don't use it very often and you forget about the stuff. So let's go ahead and let's rock and roll with our first example. All right. First off, this one has a fraction. Now, fractions aren't the end of the world, and you can do this with the fraction. A couple different ways to look at this one. And so I'm going to explain to you one way and I'm going to show you another way. So you can choose. Remember, there's usually more than one way to get the right answer. It's just a personal preference. So we're asked to solve for this value of x, right? So if I look here, x is this number here. So really, if I add 3/2 of x plus my y times my 1 there, it would equal my value of z. Now, the problem with just what I said right there, just that piece, let me go ahead and just write this out so you guys can see what I'm talking about, but it's not how I'm going to solve it. I can go this route if I want to. So what this is saying is I would have 3/2 x plus y times my 1, so y is equal to z. Now, when I look here, I have 1, 2, 3 unknowns. I want to know what this x is, but I don't know what y or z are. So I've got to figure out what those pieces are too. Now, again, I said I don't like working with fractions. So a quick, easy fix to get rid of fractions is whatever this denominator value is, multiply each one by it. So in this case, it's a value of 2. So I'm going to multiply each matrix by 2. So what I do to one, I have to do to all of them. And when I do that, these 2's cancel out, and it leaves me with 3 times my x, 6, 8, 4, plus 2y times my 1, 4, 3, 2 is equal to my 2 times my z, 6z, and 2. This is just easier to work with in my eyes because I don't have to worry about these fractions. That's usually where you guys make mistakes, and you guys just really try to avoid them at all costs. So it's just a quick, easy way to get rid of it. Now, the concept is going to be the same for what I would do if I left the fraction or not. So you can leave the fraction, solve it, and work it out that way. The idea is going to be exactly the same as how I'm going to work this out from here. I just got rid of the fraction again because you guys tend to make silly mistakes with them. So how would I go about this? Well, I'm going to go ahead and I'm going to distribute my values, these coefficients, to each term so that I can look at it as each of these matrices just as their own little set. So here's what's going to happen. So it's going to be 3 times each one of these values. So I end up with a 3x, 18, 24, and 12. I end up with 2y, 8y, 6y, and 4y. And over here, I would have 2z, 2z, 12z, and 4. Okay, so now I'm kind of back where I started in regards to, I'm still looking for that value of x. And when I write this down, again, that's the only one x there. So it's the one I have to use. It's the only x given. So, and I need to figure this out. So I'm going to have my 3x plus 2y is equal to 2z. So I have 3x plus 2y is equal to 2z. That's what I need to figure out are the pieces to this. So what is my y and z? In order to solve for x, I need to know those. So I look at what I'm given, my pieces here, and I notice that this piece right here, if I did 12 plus 4y plus 4, that only has one variable. That's the only one because all 3 of these here have a variable. All 4 of these have a variable. So this is the only one that's going to help me figure out those missing pieces of z and y. So if I take that piece 12 plus my 4y is equal to 4, I can solve for that value of y. So if I subtract 12 from each side, I have 4y is equal to -8. Divide both sides by 4. Then I have y is equal to -2. Now I know that this value is going to be a -2. Okay, well, that's great. I know that y is -2. But I still need to figure out what z is. I still have two unknowns here. So I need to figure out what z is. If I figure out z, then I could go ahead and I can solve for x. So when I look at this, I go, okay, z. Well, I can use either this piece or I could choose to use this piece. It doesn't matter because they both have a z and a y, and I know what y is, so I can solve for z. So it doesn't matter which one you chose, but remember, if I'm choosing my row 1, column 2 spot, I need to make sure I'm using that equation all the way through. So I'm going to go ahead, I'm going to choose this one right here to help me solve for my z. So in other words, I'm going to take 18 plus my 8y is equal to 2z. And I know that this y value here is a -2 because we just solved that. So I have 18 minus 16 is equal to 2z. So 2 is equal to 2z, then z has to be a value of 1. Awesome, now I know that this z right here is a value of 1. I fill in the rest and I can solve for my value of x now. So I end up with 3x, oops, I put in my y's and z's, sorry. Let me fix that, that's not right. Let me redo this piece, throw you guys off. Okay, so it's gonna be, sorry, this is gonna be 2 times my y value, which we said was -2 is equal to 2 times my z, which we said is 1. So I end up with 2 times a -2 is going to give me my -4 is equal to 2. I'm going to go ahead, I'm going to add 4 to both sides. And I end up with 3x is equal to 6. So x must equal 2. And this is our final answer. X is equal to 2. So they want x is equal to 2. Again, this isn't the only way. I just think I prefer not to work with the fractions because again, it throws you guys off, adding, subtracting with them, with all these variables. You don't have to get rid of it. You could have just distributed that through here and had a 3/2 x, and it would have been a y plus y is equal to your z. However you want to go about it, this concept here is still going to be the same, whether you left the fraction or not. The numbers would be different, but the concept, you'd have to solve for your y first. You would have to solve for a z, and then you can go ahead and solve for your x. So it's a good problem, a lot of your algebra, basic algebra skills being used in it. Questions before I continue, because there was kind of a lot in that. Any questions? I tried to color coordinate it to help you guys visualize the different steps. Alrighty, my next one. This one I think is one of the more basics. I think you guys can do this one pretty easily. So I have that x minus a is equal to b. And it asks me then, what is x? I want x. So if I want x, I'm going to add a to both sides. So x is equal to b plus a. So all I need to do is add my matrix b to my matrix a. So I have x is going to equal, my matrix B was -9, 5, 1, -1. It's these matrices right up here. Plus my 2, -7, 6, and 1. And I end up with -9 plus 2 is going to be a -7. 5 plus -7 is a -2. 1 plus 6 is going to give me 7, and -1 plus 1 is going to give me a value of 0. And there we go. It's going to be this option right there. Make sure you're matching them up. Make sure you check all your numbers so that you don't accidentally pick the wrong one, even though you got the right answer. That's always the worst. Alrighty, next one. That side. All right, so again, we're given two matrices, we're given Y and Z, and we're asked to solve for matrix X. So again, I like to just do the algebra piece of this first. So I have 1/2 X, X plus Z is equal to Y. So our goal is to solve for X. So I'm gonna go ahead and I'm gonna get X by itself within this equation without worrying about the matrix portion, without writing them as a matrix yet, because that throws you guys off. So first thing I would do is I would go ahead and get rid of my fraction. So I'm gonna multiply this side by 2. And what I do to the left side, I have to do to the right side. So my 2's cancel out and I have X plus Z is equal to 2 times my matrix Y, 2Y. And again, we're solving for Z, so I'm going to go ahead, or solving for X, so I'm going to go ahead and subtract my value of Z. So I have my X is equal to 2Y minus Z. So I'm going to do 2 times my matrix Y, and then I'm going to subtract my Z. So it's going to be my 2Y is going to be 2 times each one of these values for my 2Y. So my 2Y is going to be 8, 16, -6, and -12. So when I want to solve for that X is equal to, it's going to be my 2Y, which is going to be my 8, 16, -6, -12, minus my Z, which is this matrix right here, -1, -2, 7, and 2. And then I'm just going to go ahead and subtract them. Remember to watch out when it's minus and negative, make sure you flip your sign. So don't make those silly mistakes. So I have X is going to equal 8 minus a -1 is going to make that 8 plus 1, which is 9. 16 minus a -2, so it's going to make that plus 2 is going to give me 18. -6 minus 7 is a -13. And -12 minus 2 is a -14. And there's my answer. All done. Am I going too fast or any questions? All righty. So my next one. This one can be tricky for you guys. So I want to talk about this one. Definitely why I picked this one. It says, it's really nice because I set up the equation. So it says the number of girls, G, in a room is 4 more than 2 times the number of boys, B. Okay, so girls is 4 more than 2 times the number of boys. That's where this equation comes from. So this equation, what this says right here is this equation. Half of the number of girls in the room, so half the number of girls in a room minus the number of boys is 2. So this piece right here is where this equation comes from. So you didn't even have to write them yourselves. That's great. So it says, which is true below. So they took our equations and they're writing them as a matrix, and then they have this piece that goes with it, and I'll talk about this piece in a second. So let's look at the equations themselves. In order to write them as a matrix, I need to get the real number by itself. So the variables all need to be to the left, and I want my real numbers right. So I'm going to go ahead and I'm going to move this over. I'm going to subtract 2b from both sides so that I have G minus 2b is equal to 4, and I have my 1/2 G minus b is equal to 2. So when I do my matrix, I'm going to have, remember our system that we've been writing? We were doing it with x1, x2, x3. This one, so what it's equal to, 4, 2. It's GB, so it's GB. And when I line up, this is going to be my equation 1, equation 2, and my GBs are going to be lined up going down. So G coefficient here is that imaginary 1 and 1/2, -2 and -1. So I look here and I go, oh, look, they're all the same. So that really didn't help. Like, it didn't help me eliminate any of my options. So I really need to focus in on my piece over here. Okay, well, if you remember, if I find the determinant of something and it's equal to 0, there's no inverse, so we can't find that solution. Because remember, when we solve this, we would do our matrix A times some unknown is equal to B. I would have to take the inverse of each side, right? Take the inverse of my A and multiply to each side. So X would equal A inverse times B. Now, if there's no inverse, can we solve for X? No. So if there's no A inverse, so we need to figure out, is there an A inverse? And if so, that would help us be able to solve for it. So let me look at this piece. I go here and I go, okay, well, my determinant, because that's how we find the inverse, 1 over the determinant of A is equal to 1 times -1, which is -1, minus 1/2 times a -2 is going to be, so it's minus a -1. So that makes it +1, which is 0. That means that there is no inverse. If there's no inverse, then we can't solve for the number of girls and number of boys, right? That's what X represents. There's no inverse, then we cannot solve for the number of girls and number of boys. So these cannot be correct. These cannot be correct because we cannot solve for it because there is no inverse of A. We cannot solve for this piece because there is no inverse. Well, what does that mean then? Does that mean that there are an infinite amount of solutions or no solutions? How do I know? Okay, well, an infinite amount of solutions happens when you have the same equation. When it's no solution, then that happens when you have something like you would have an equation where you would have like 2 is equal to 4, and that's not true. It's not a true statement. Here, it would be a true statement. It'd be something like 2 is equal to 2, or if I look here, these are my two equations. What happens if I multiply this equation by 2? If I did that, then I would end up with 2 times 1/2 is G minus 2B is equal to 4. And look what that is. That's this equation. They are the same. Since they are the same equation, they're equal to each other. They're the same equation. That means that it's going to be infinite solutions. So if you have the same equation, then you would know they were going to have infinite solutions. If you saw that right away without finding the determinant, you would automatically know that it was going to be infinite solutions. If they're the same equation, so they're equivalent, and some of you guys say, but they don't look the same to begin with. They're equivalent. If I multiply everything by the same value and they're the same, it's just two different ways to write it. They're still equivalent. Just like 2 is the same thing as 6 over 3. They're equivalent, they're the same value, they're just two different ways to write it. So same thing's happening here. So if that's the case, that means that there are infinite solutions. If I had something here and I was trying to figure out G or B and I ended up with something that looked like this, then that would be no solutions. If I was able to find my inverse, if I was able to solve for X, then whatever number was up here would represent my number of girls. Whatever number was here would have represented the number of boys. So that's how you would get 4 or 0 or 8 and 0, whatever it is. So that's how you would come up with those pieces, is if you are able to solve for that piece. Any questions? Because that's a lot of information, throws you guys off with the no solutions. The easiest way to check is if it's going to be, if there's not going to be an inverse, would be finding the determinant. That's going to tell you right there. All right, well, best of luck on your quiz today. If you guys have questions, let me know. Otherwise, I will talk to you guys later. Take care.